Welcome. Let's take a look at an example where we want to define a fifth-degree polynomial with real coefficient, and we want to make sure that that function has the following solutions: at x equals 5, at x equals 2i, and at x equals I. And then, in addition, we want to make sure that this function passes through the point f evaluated at -1 equals -180. Well, let's try to build a strategy around this. Our polynomial of f of x, we want it to be of the fifth degree. So if we want a function to be of the fifth degree, we need to identify 5 solutions. Because we want to identify the 5 linear factors that we can use to identify this function. But within the description, we are being given 1 solution, 2 solutions, 3 solutions. So let me write them down. At x equals 5, at x equals 2i, and at x equals I. So we are missing 2 solutions. How are we going to get those solutions? Well, notice that the solution of 2i, it's a complex number. And x equals I, it's also a complex number. Well, don't forget that when we have a complex number as a solution, the complex conjugate is also a solution. So if 2i is a solution, the complex conjugate, it's -2i. We switch the sign of the imaginary part. And if I is a solution, then -i is a complex conjugate, and therefore a last solution that we were missing. And now that we have the 5 different solutions, then let's define the 5 different factors that we will be using to define this function. If x equals 5 is a solution, then x minus 5 is a factor. If 2i is a solution, then x minus 2i is a factor. If -2i is a solution, then x plus 2i is a factor. If I is a solution, then x minus I is a factor. And if -i is a solution, then x plus I is a factor. With all this information, we can start defining our fifth degree polynomial. It is going to look like f of x. Our coefficient, we do not know what it is, so I'm going to leave it as a, times the multiplication of the 5 factors that we found. So when we just consider this function that we have here, we are going to define a fifth degree polynomial with the solutions of 5, 2i, and I. So let me erase some of my work to give myself some space to continue with the problem. We're going to take care of this coefficient in a second. What we would like to do, we would like to multiply all these 5 different factors. But you always want to multiply it in pairs. And let's be strategic. Which pairs are we going to multiply first? This second and third factor, they are factors from complex conjugates. So we're going to multiply those 2. And the same goes with the fourth and the fifth factor. They come from complex conjugate solutions. We're going to multiply them as well. This is going to simplify our calculation. So let's bring everything down and perform this multiplication. Let's start by distributing this x. This is going to be x squared. Now let's distribute to 2i, so that's going to be positive 2xi. Now let's distribute this -2i, distribute to the x, -2xi. Let's distribute to the next one, that's going to give us -4i squared. Now let's multiply these 2 factors. Let's distribute the x, that is x squared. Let's distribute the x, so that's xi. Let's distribute the -i, so that's -xi. And let's distribute the -i, so that's -i squared. So even though this is starting to look a little bit complicated, notice that when I concentrate on this result of our multiplication, which is when we were multiplying these 2 factors, complex conjugates, these 2 expressions are going to cancel out. 2xi minus 2xi, that's 0. So they cancel out. And then in addition, we have I squared. But don't forget that this is equivalent to just -1. So the result, we're just going to get x squared and -4 times -1, that is just +4. So this is more simple. And this is why we want to multiply complex conjugates with each other. They will always simplify for each other. And when I multiply the 4 and the 5th factor, notice that the same thing happens in here. Those with an I, they will cancel each other. And then in addition, we have I squared, which don't forget that that's equivalent to -1. So now we're just going to get x squared and negative times -1, that is +1. So now we went from 5 different factors to just 3. And it's starting to look a little bit more simple. Let's keep expanding this a little bit further. Now, it doesn't really matter which ones you want to multiply now, but I'm going to multiply the 3rd and the 4th. When we distribute x squared, that's going to give us x to the 4th. When we distribute x squared, that's going to give us positive x squared. When we distribute the 4, that's going to be 4x squared. And let's distribute to the 1, that's going to give us just 4. Here we can simplify these two expressions. They both have x squared, so now that becomes 5x squared. All right, we're almost done with this. There's only 2 more expressions to be multiplied. So let's start by distributing the value of x. That's going to give us x to the 5th. So now let's distribute to the next one. That's going to give us 5x to the 3rd. Distribute to the next one. That's just going to give us 4x. Now let's distribute this -5 to the first, -5x to the 4th. Distribute to the next one, -25x squared. And lastly, distribute to the last one, that will be -20. So we're almost done. Now let's just rewrite this in standard form, from the highest to the lowest exponent. So here we have the function that we are looking for. This function that we have defined here, it is a 5th degree polynomial. It has real coefficients. Notice that there is no imaginary numbers on it. And we are guaranteed to have the following solutions. But this is not the final result that we will consider, because we're still missing this condition. We want to make sure that this function, when we evaluate it with an x value of -1, we want the output to be -180. And this condition is what we're going to be using to properly define the leading coefficient of a. Within this function, let's substitute the value of x to be equivalent to -1, and let's set our equation be equivalent to -180 degrees. And with that, we're going to properly define the leading coefficient of this function. So let me write some work to give myself some space. So now we have the following. F of x, let's plug in -180. A, which is the leading coefficient, it's what we're looking for now. And now let's substitute -1 for every single possible value for x. So let's evaluate what we have. -1 to the 5th, that's just -1. -1 to the 4th, that is +1, times -5, that is -5. -1 to the 3rd, that's -1, times 5, that is -5. -1 to the 2nd, that's +1, times -25, that is -25. -1 times 4, that is -4. And let's bring down the -20. Let's continue our calculation. Let's bring 180 down, the value of a. And now, all this expression on the right-hand side, when we combine it, that's equivalent to -60. And finally, to solve for a, let's divide by -60. So we are done. The coefficient that we want to use is when a is equivalent to 3. So now we have our final result. The polynomial that will satisfy every single condition in this problem is when we have 3 times what we initially had from those factors. It is definitely a lengthy process, but having strategy helps us a lot to obtain this result. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.